I'm looking at additional in C, the dynamic memory allocation, memory model, and linked list. So for this, I have collected some links as well, but for now I'll use this book to talk about them. So Unit 4 additional in C, and we have dynamic memory allocation, Malloc, size of and free, Kellogg and relog. These are the two types. So the look at the words here. Dynamic memory allocation is Malloc, size of and free, Kellogg and realloc. Allocation, call allocation, reallocation. Memory model, linked list. Inserting of a node in a recursive program, deleting specified node in singular linked list. Inserting a node after specialized node in singular circular linked list. Two words here. It's memory and it's the concept of a linked list. So static representation of a linear order list through array leads to wastage of memory in some cases of overflows. So no, we don't want to assign memory to any linearly in advance. Instead, we want to allocate memory as they are inserted in the list. This requires dynamic memory allocation. Dynamic memory allocation is pretty unique to C among high-level language. It enables us to create data types and structures of any size and length that suits our program. So malloc, size of and free. The function malloc, malloc, is commonly used to attempt to grab a continuous portion. It is defined as void malloc size key number of bytes. This is to say that it returns a pointer type void that starts in memory of reserved portion of a size. If memory cannot be allocated, a null is returned. Since star is returned, C standard states that pointer can be converted to any type. So character star CP, CP is equal to malloc 100 attempts 100 byte and assign the start address to CP. It is usual to use the size function to specify the type of integer star in star int star and malloc 100 into size int. Some C compiler may require to cast the type of conversion. Int means conversion to an integer pointer. Conversion to the correct pointer is very important to ensure point arithmetic is performed. It's a good practice to use size of even if you know the actual size. It makes device independent portable code. Size of can be used to find out size of a data type variable. Simply supply one of these arguments to the function. So when you have finished up a portion of memory, you can always write free. This allows memory to be free. And then we have Kellogg and relog. So these are two additional allocation functions. Their prototypes is void star Kellogg, size of element and size t num element, size t element size. Relog is void star ptr, size of new element size. Malloc does not initialize the memory to 0 if anyways. If you wish to initialize memory that uses Kellogg, there is slightly more computation but occasionally more convenient than malloc. Also note different syntax between Kellogg and malloc. Kellogg takes number of desired elements, number of elements and element size to individual arguments. To assign 100 integer elements, we need to initially 0. So int star in int star ip is equal to int star Kellogg 100 size of int. Log is a new function which attempt to change the size of the previous allocated. The new size can longer be smaller. The original block size cannot be resized in relog. Will attempt to assign a new block of memory and will copy the block elements. Note new point of difficult value will consequently be returned. So malloc allocates memory and return pointer to the first byte space. Kellogg allocate the memory space, initialize them to 0 and returns the pointer to the first byte. Free previously allocated memory and relog modifies size of the previous SO. So this is the dynamic memory management function. So malloc, Kellogg, free, relog. If anything related to this dynamic memory function, this chart is very important for you in that terms. Then memory models. Memory model in C language are way to specify assumption that compile should make. So memory segmentation, pointer size, memory model. Then we have concept of linked list. An array is represented using a sequential mapping which has the property elements of existing apart. But this has the following this. It makes insertion or deletion at an arbitrary positionary a costly operation because this involves the movement of some existing element. If you want to represent several lists of arrays by using arrays of variant size, either we have to represent each using maximum size or we have to represent each list using one single array. So here is the program to building and printing elements of a linked list. Advantage of a linked list, representation of a linked list. So then we have a linked list as our two topics. So This topic is memory allocation and linked list. Broadly talk about that.